let's do this for another problem where we're going to again need to set up this table and identify the vertices. I'm going to start at the top left with 545 and substitute those in for x and y. Going clockwise, we have 45, 45, and now I can slide this down a little bit. 45, 10, 25, 15, and finally 10, 30. Those will be the values being substituted in. Now the equation we're working with will be z is equal to 1000x plus 900y. So let's start by going 1000 times each x value. We will have 5000, 45,000, 45,000 again, 25,000, and 10,000. And I'm going to just draw my plus signs going straight on down here. Now I need to go 900 times each. First one will give us 40,500, whoops, and those will add up to 45,500. Again, 40,500, but this time it will add up to 85,500. 900 times 10, that'll be 9,000, and those will add up to 54,000. 900 times 15 gives us 13,500, and those will add up to 38,500. This next one will be 27,000, and those will add up to 37,000. And this problem, if we go back up to the top, says we want to minimize, and so the smallest value on that chart occurs way down here at the bottom. There's our minimum. So I'm going to go up here and write our answer. Part A, the minimum will occur when x equals 10 and y equals 30. And part B, the minimum value is going to be 37,000. Okay, now they have been giving us the feasibility region for these first two problems. Now we want to come up with that on our own. The first two equations that were given, the two inequalities, basically tell us we're going to be in the first quadrant. The second one, if I rearrange this, I would have y less than or equal to negative 2x plus 40. So if I put my y-intercept there at 40 and I go down 2 over 1, or down 2 equal units and over 1, I can get this equation, or that line, and we will be shading below it. This bottom inequality, if I rearrange that, I begin with 2y less than or equal to negative x plus 50. Divide through by 2 to get negative 1/2 x plus 25. So I get a y-intercept of 25. It's going to intersect right there and go over. And we're shading below here also. And we will have this region down on the bottom left where it is bounded by the x and y axis. Now I need to identify those vertices. So on the top left there I have 0, 25. This point of intersection is 10, 20. Down on the bottom right I have 20, 0. And we have the origin, which is of course 0, 0. So those will be the vertices of that polygon that was formed inside. Now we are asked to find the maximum value of this objective function, and that means we will need to create this chart again. Starting in the bottom left corner we'll have the origin. Going clockwise we have 0, 25, 10, 20, and 20, 0, and they're being substituted into 9.2x plus 8.1y. So I'm going to fill up this x column first. 9.2 times 0 is 0. We're going to have 92 and 184. Let me put my plus signs going down. We will have 0. 8.1 times 25 is 202.5, followed by 162, followed by 0. We will then add each of these up to get 0, 202.5, 254, and 184. We are looking for a maximum. That's the 254 there. So that will occur when x equals 10 and y equals 20. And then in the bottom of the page here, it wants to know what the maximum value is. That answer is 254.